Hi, welcome all. In this video, we shall be discussing about the Bohr atom model. And in this part, the Bohr atom model is divided into three parts. In this part, we shall be discussing about the radius of electron orbit. So, in 1913, Niels Bohr put forward a theory about an atom that meets with some success. You all know there were several models of atom put forward by different scientists. However, the first semi-successful model was proposed by Niels Bohr. Of course, this is not a perfect model. It has got several drawbacks. However, it was successful in explaining at least hydrogen spectra and hydrogen atom. Okay, you know all the details, and the idea of Bohr's postulates and all, he postulated several things, and based on the postulates he proposed that model. But there is a natural way to arrive at the same theory, that is using concept of matter waves, and this method will be discussed in this video. However, Bohr used a different approach, and the reason is obvious. At that time, de Broglie's work was not published. It actually came a decade later, and due to that reason, our Niels Bohr was totally unaware of the concept of matter waves. Fine, it was introduced a little bit later, a decade later. Fine. And the most surprising thing is this: the results are exactly the same. So in this video, we will start with the concept of matter waves, and we will arrive at the Bohr model of atom. Next, we shall derive the radius of an electron orbit. So we know that there is a positively charged nucleus, and electrons, they revolve around the nucleus. We know that the electrons are negatively charged particles. So this negatively charged electron, they revolve around the nucleus with some speed v, with some along a circular track of radius r. We all know that for such a circular motion, some centripetal force is required. So some centripetal force is necessary. So I can write the centripetal force, F centripetal, and that is provided by the electrostatic force between the positively charged nucleus. We know that the charge is some plus E for this one, and for the electron it is some minus E. So this is our nucleus. Basically, hydrogen atom contains only a proton in the nucleus, and this is our electron. Its charge is negative, and this V stands for the velocity. Okay, fine. So there will be some electrostatic force of attraction between negatively charged electron and the positively charged nucleus. So I can write the centripetal force is nothing but the electrostatic force, F electrostatic. So I can write the centripetal force as m v square by r. We all know that the centripetal force is given by mv square by r, where v is the speed, r is the radius. And electrostatic force is given by the formula 1 by 4 pi epsilon 0 Q1 Q2 by R square. Here Q1 is charge of electron and charge of proton, then divided by R square. So you can cancel one R. You can cancel one R on either the side. I'm going to cancel one R here and one R from R square, and I can take M to this side, which gives V square equals E square divided by, that's in the numerator, then 4 pi epsilon 0. I'm going to take M to the other side, M R, and that readily gives you an equation for the speed V as root of this quantity. Root of E square is just E, and root of 4 pi epsilon 0 m r. Okay, so the speed is given by E divided by root of 4 pi epsilon 0 mr. So let me call this as equation number 1. So this is the speed with which the electron revolves around the nucleus. That's very simple. Now the next step, we will calculate the de Broglie wavelength. Okay. De Broglie wavelength or matter wavelength. De Broglie wavelength is given by lambda equals h divided by gamma mv. Since this speed is much less than c, we can ignore the relativistic effect, and therefore we can take gamma as 1. That gives lambda is equal to h by mv. Correct. Now we already have the formula for V. We will make the substitution. Substituting, we'll get lambda equals h divided by, here you have one m, then I'm going to substitute V. V is E divided by root of 4 pi epsilon 0. So this divided by square root of 4 pi epsilon 0 mr. Okay, so this can be written as h divided by me into root of 4 pi epsilon 0 mr. Upon simplification, we'll get this as h divided by E. See, you have one m here in the denominator and you have one root term in the numerator. Okay, so upon simplifying, you will get root term in the denominator. So I'm going to write everything as a single radical. I'm sorry. H by E into square root of, so what all are there? 4 pi epsilon 0 r divided by m. Correct? So this is the de Broglie wavelength. Okay, lambda is equal to h by E into root of 4 pi epsilon 0 r divided by m. Okay. Now we are considering the electron as a standing wave, around the nucleus. So this is the electron trajectory, and the electron wave must be a standing wave, something like this. Something went wrong. Okay, so let me redraw it. So something like this. Okay, so if you stretch, it may look like this. If you break the trajectory, and if you plot it, you may get something like this. Okay, okay, now you just circle this, you will get this thing. Okay, so you just take both the sides and make this string a circular loop. Okay, so you will get this figure. Alright, so here you can see that this distance is one wavelength and this distance is another wavelength. Okay, now consider that you are joining both the ends. Then this condition still exists. That means node will not change, so that you will get a stable pattern, something like this. Correct? And if the length is not exactly n lambda, so here we have considered the case that the length of the loop is L is equal to the length is n lambda. So in that case you will get a consistent pattern. Alright, if the length is not exactly n lambda, destructive interference will take place, and all of a sudden the standing wave disappears. So in order to get a stable path, the electron orbit must be an integral multiple of its wavelength. So this point is really important. So for stable orbit, the condition is this: the orbit length, that means the circumference, the length of the orbit must be equal to n into lambda. And what is n? N can be 1, 2, 3, etc. And what is lambda? Lambda is the wavelength. Okay, so by considering the electron as a wave, we must consider the electron around the nucleus as a stable standing wave, and for that the length of the orbit must be n lambda. So if you are considering the radius of the orbit as r, then the length of the orbit is obviously 2 pi r, and this must be equal to n lambda. Correct now. So that must be equal to n lambda. Now the point is this: there are several such possibilities. For n is equal to 1, you will have a particular radius, and for n is equal to 2, you will have another radius. Correct? For a larger one, For example, if this is for n equal to 1, then you will have R2, which is little bit more for n is equal to 2. So you can have different possible radii, R1, R2, etc. So let us consider nth orbit. So we'll add a subscript Rn. Be very careful. This is actually a subscript. You should not cancel this n with this n. So you must be very careful. And we already derived an expression for the de Broglie wavelength, that is lambda. We already have what is lambda. Lambda is h by e into square root of 4 pi epsilon 0 r divided by m. For nth orbit, this r is nothing but Rn, so we'll have another n there, correct? Fine. Now substituting these values on either the side, on RHS, you will get 2 pi Rn is equal to n into, what is lambda? Lambda is h by e into square root of 4 pi epsilon 0 Rn divided by m. Now I am going to square it. For simplicity, squaring, you will get 4 pi square Rn square is equal to n square h square by e square into 4 pi epsilon 0 Rn divided by m. Now I am going to cancel common terms on either the side. You have 1 4 here, you have 1 4 here, you have pi square here, you have 1 pi here. I cancel that. There is one Rn on the RHS. There are 2. We cancel 1 on the LHS. Anything else? Hope we have finished everything. That gives Rn equal to, you have n square into h square is there, epsilon 0 is there, divided by here 1 pi is there on the LHS. I'm taking that to the RHS, so pi. Then there is one m in the RHS, and you have one more time e square. Okay, so the final formula is this: nth radius of the nth orbit is n square into h square epsilon 0 divided by pi m square. So this is the radius of nth orbit, correct? Fine. Now for n is equal to 1, you will have R1 as h square epsilon 0 square divided by pi m e square. And you can see that all the terms are constant. H is Planck's constant, epsilon 0 is permittivity of free space, pi is constant, m is mass of electron, E is the charge of electron. So everything is constants, and everything are constants. When you substitute all these values, you will get it as 5.292 into 10 raised to negative 11 meters. And roughly you can remember this as some 5.3 into 10 raised to minus 11, or 0.53 into 10 raised to minus 10 meters. That is roughly some 0.53 angstrom. Okay. So please remember this value, right? So this value of radius is called Bohr radius. And we represent Bohr radius with A0. Alright, with that substitution, you can write Rn as Rn equals radius of the nth orbit as n square a0. Okay, and what is a0? What is a0? A0 is nothing but Bohr radius and is equal to h square epsilon 0 divided by pi m e square. Correct. So this is the radius of nth orbit. So electron cannot revolve in any orbit. Instead, they can revolve only in these orbits. Can have the radius a0 or 4n0. When n is equal to 2, you will have n square as 4, then 4a0. Then when for n equal to 3, you can have 9a0. So the radii are. So we have this formula, Rn is equal to n square a0, and a0 is nothing but 0.53 angstrom roughly. Correct. Now, not every orbits are permitted. Okay, only these orbits. For n equal to 1, you can have the radius as a0. And for n is equal to 2, we know that Rn is given by n square a0. For n is equal to 2, it will be 4a0. For n is equal to 3, it will be 9a0, so on and so forth. So that means if this is the first orbit having radius a0, the second, this is for n equal to 1. For n equal to 2, its radii must be 4 times a0. Correct? This is 4a0. Then this must be the n equal to 2 orbit. And for n equal to 3 orbit, you must have even greater radii, that is some 9a0. So it must be more than this. Okay. So please note that the radii are not equally spaced. Correct? For instance, the distance between the first and second orbit is just 3a0, while the distance between the third and fourth orbit is 5a0, and for the next one it will be 7a0, so on and so forth. Correct? That means the radii are not equally spaced, and electron can either revolve at this particular distance or at this distance. In between these two, electron cannot exist. Understood? So electron is prohibited from revolving in orbits whose radii not equal to some integral multiple of a0. If these electrons are prohibited from these orbits. Correct? So you cannot have an electron, you cannot see an electron which revolves in an orbit of radius which is not an integer multiple of a0. So this is not possible. So that's it. Thank you. We will be discussing the energy levels of the electron in hydrogen atom in the next part of this section. Thank you.